So hello and welcome you all. So here we are again in robotics lab and we have the second experiment, that is the encoder. So this is the encoder sensor we have here, you can see. So previously what we did is that potentiometer, this is the rotary potentiometer. So basically the working principle, the main motive of the experiment of both the sensors are almost same. That is, we are getting the angular position, fine. But in this encoder we are getting some more data, some additional data we can get. For example, the angular position we are getting obviously fine. Then we can get the direction and also we can get the velocity, fine. So this is the sensor we can see here, and in the sensor you can see this is the basic knob we have here. So basically this knob is given for rotate this, so we can give some rotation here, fine. And you can see we have some sensors here. So this is the one sensor, this is the one sensor, and one more sensor we have here, fine. This is one more sensor and this is the other sensor. So basically these sensors are given so as to emit some source. So these sensors basically these are emitting some source and also simultaneously receiving, fine. Something it is emitting and something, and again it is receiving back. And we have some LED bulbs blinking here, fine. So you can see here we have some empty position. This is the empty part we have here, and again we have some slot. This is the covered part and this is the uncovered portion and this is the covered portion, fine. So as soon as this covered position faces the sensor, the LED blinks. Now this is the covered position, it is facing this sensor, as well as this covered position, it is facing this sensor. And because of this thing, the sensor is facing this covered position, we can see the LED is blinking. These two LEDs are blinking. Now suppose if I move it little bit in any direction, let's say in anti-clockwise direction if I move, so you can see now this covered part has come out of the sensor position. Now it is not facing the sensor, and because of that this LED is not blinking. But still this one is facing, this covered position is facing this sensor, and this LED is blinking. And if I move it again in the anti-clockwise direction, so none of the covered portion is facing the sensor. So you can see both the LEDs are not blinking now, fine. So the basic idea is that these LEDs are given so as to know that the covered portion is facing the sensor, as well as the sensor is reading the value, fine. So this is the basic working of the sensors, how the sensor is working and all, fine. This is the knob we have here. And one more thing from the top, you can see here we have a screw here, some kind of thing you can see. This portion, this screw, this is a metallic head you can see. So this metallic head, if you go down a little bit, and you can see this metallic head is coming here. This one, this is the metallic part, it is coming here. So basically this is giving us the rotational value, fine, because it is connected here. And if I move this knob, this head will follow this complete portion, fine. So, and we have some sensors on the board, so this sensor is reading the data. So now suppose this is the initial position, you can see the LED is not blinking because right now it is covering the LED, fine. Previously when the slotted portion was facing this sensor, the LED was blinking. Now this slot is facing this portion, this is the circuit you can see. This is the circuit, and this is the slot. This is the slot, it is facing the circuit, so it is covering now and the LED is not blinking. Now if I give one complete full, this one, if I move it and if I bring it back to this circuit, again it is facing this circuit, you can see the LED is not blinking. That means it is giving us the one complete rotational value, fine. So let's see. So coming back here, what we can see is that now the sensor which we are reading is that encoder, ENCODER, encoder sensor. And the encoder sensor, what are the things it is giving us? First of all, the angular position it is giving us, fine. Secondly, it is giving us the direct velocity we can easily calculate, and we can also get to know the direction. Fine, direction is very important, in which direction we are moving, maybe in plus minus, or maybe in which clockwise or anti-clockwise, which direction the motor is moving, the sensor is moving, the angular position, and also the velocity. So these three things we can get to know from this encoder sensor. So talking about the basic structure, so this is the encoder we have here. Fine, and here we have some slots. That is the covered position. This is the covered position. This is the covered position we are having here. So fine, these are the covered position, and the empty spaces are uncovered position. And we have two different sensors. Again, we have two different sensors here. Fine, these sensors are emitting some source and receiving some source. So when there is empty position, it will just emit, and when there is covered position, the slot, it will give the signal and receive it back. Fine, this is the knob shaft from where we can rotate it. This is the shaft, and here we have that metallic screw. Fine, the metallic screw which I have shown in the board. This is the metallic screw, and from the metallic screw we have some shaft going in the downward direction, so as to collect the values from the sensor board. So this metallic head is going in the downward direction. This is this one, the metallic head, this metallic head. Fine, it is going in the downward direction, so as to read the value of the values in the circuit which we are getting. Now the use of this one is that if I rotate this knob in this direction, this is the knob, and if I move it in this direction, fine, so it will also move. Fine, and if I bring it in the exact position, from the initial position I am moving it and bringing back the knob to the initial position, so it will, the sensor will read the data, and it will say that I have covered 360 degree. And from the LED, the middle LED, the LED which we have in the middle section will also give us the value that yes, we have moved 360 degree. Fine, so this is the basic use of this sensor. And we have in the sideways direction, we have two sensors. Now the question is that if this sensor is emitting something and receiving something, that is in the empty position, it will emit something. So since it is empty, it will go back, and when it faces the covered position, it will strike, the sensor will send something, it will strike from the covered position, it will receive back, and will get something value in 0 and 1. Fine, because of this sensor. Now what is the use of other sensor? Why we are using two different sensor? Because this sensor is satisfying our need. We need the value in 0 and 1, whether it is covering the covered position or whether the sensor is facing the uncovered position, whatever may be, it is satisfying our need. Then why do we have the other sensor? Because these sensors are doing almost same thing. Fine, this is also emitting, this is also emitting. Now the reason is that we have two different sensors is that it will, because of two different sensors, it will give us the relative position. Now this sensor, let's say sensor A is facing this way, and sensor B, fine, position at this location, and at this location sensor A and B, and if we are moving in this direction, so it will know that it is cutting this slot also and cutting this slot also. Fine, and because of that, the relative position between A and B sensors are changing, and because of this relative motion, it will say that it is moving in clockwise direction. And if I again move it in the opposite direction, and because of this relative motion, because the sensor are placed in such a way and calibrated in such a way, it will cut the covered part and uncovered part in such a way that it will give us that if I move it in this direction, it will give us the motion in anti-clock. So because of two different sensors, we are also getting the direction, in which direction we are getting, maybe in clockwise or anti-clockwise, or maybe in positive or negative. Maybe we'll get some value in positive, or maybe we'll get some values in negative. Fine, so this is the basic structure. Now talking about the slots, how many number of slots we have in the system. So talking about the slots, this is the covered portion, I'm calling it slot. Fine, so cover position or slot, same thing. So how many slots are there, we need to know, because we know this is a circular part, and the total angle we have here is 360 degree. If we need to divide a single part, if I need to know the angle only, the sensor cutting only this position, the sensor which we have here, it is giving us the values for only this position. So for that I need to know how many number of slots are there, and if I know the number of slots, what will I do is that I will just divide 360 divided by number of slots, so that I will get the value only for a single slot, the single slot where the sensor is receiving the data, whether it is cutting or emitting or receiving. So we will know. So what we will do is that here in this system we have 9 number of slots. Like suppose here we have 1 slot, here we have 2 slot, here we have 3 slot, 4 slot. So likewise we have 9 number of slots. So total angle is 360 degree and the number of slots we have here is 9. So we get 40 degree. Now 40 degree is the angle which the sensor will cut only for this a single slot or the covered position. This is the covered part of the slot. So only for cutting this one or only for recognizing this one, the angle will be 40 degree. That means from this position, from this slot to this slot, fine, from this slot to this slot the angle will be 40 degree, because the initial position, like suppose the right now the sensor is facing this part, so this is the initial. If I give some rotation and bring the sensor to this portion, so this is the part we are left, the uncovered part, so we have 9 number of slots here. Similarly we have 9 number of empty slots here. So because of that 360 divided by this portion will give us the least count, that is 40 degrees. Fine. This is the basic thing of the software, basic thing of the the sensor. Now what we'll do is that we'll find the angular position. Angular position we will find. For finding the angular position, we need to know the pulse, P-U-L-S-E, pulse per revolution. That is important thing we need to know. Pulse per revolution is that the same thing what I have told you, that is this one. So if I move this slot, move this sensor in clockwise direction or maybe anti-clockwise direction and give one complete rotation, that is 360 degree, how many number of slots it is covering? That is the main idea. This is the pulse. Now in the software you will get, if I give one complete 360 degree rotation, if I give it to this sensor, I will read some values like this. Fine. Now if I give 360 degree rotation, I will get these pulses. Fine. So for 9 slots I am getting 9 pulses. 1 2 3 4 5 6 7 8 9. Fine. 9. 1 2 3 4 5 6 7 8 9. So 9 pulses. So these are the pulses we are getting for 360 degree rotation. So in the software I'll see. Okay, so this is the software. So first step is select the device and hit run. Fine. Okay, so you can see this is the pulses per revolution, that is 0, and angle it is showing infinity. Fine. Now in this case where I don't know the pulses per revolution, and if I move this sensor, I'm moving the sensor. Fine, I'm moving the sensor. So it is reading all the data, the zeros and ones, the highs and lows it is reading. Where the sensor is cutting the slot, it is receiving the data. It is also calculating the H count. I will tell you what is H count, but it is not giving us the angle value because we don't have the pulse per revolution value. Once I enter the pulse per revolution value, it will give us the angle. Now talking about what is H count. Now when the sensor is cutting, so you can see one more thing, like okay, now both the LEDs are not blinking now. If I give some rotation, I'm given some rotation. Now this sensor is detecting something, so this is blinking. So this is one H count. Now if I rotate it, okay, now this sensor is receiving some data, that means it is cutting, it is striking. Now this LED is blinking. I move it now. Now this one is not blinking, one more edge. So zeros and lows, whatever may be, we are getting 0, the signal as 0, it will count as one edge. When we are getting 1, digitally 1 value, it will count as one edge. maybe 0 or 1, anything, it will count as one edge. That means whenever the sensor is striking and getting some value, it will give us, this is the edge, this is the number of edge we are getting. So basically when we are getting the graph here, this is the graph in the screen, and when we are getting, so this is the edge, this point is one edge, this point is one edge, or maybe this point is one edge. So these are the edges we are getting. Fine, maybe this one is one edge and this one is one edge. So whenever it is cutting the covered position, it will give us one edge, and that is the edge count. Now what I know is that the number of slots is equals to 9. Sorry, we have 9 here, and we have given one complete 360 degree rotation, and when we give 360 degree rotation, all the 9 slots are covered. So I know that, and if I divide that value, 360 divided by 9, I get 40 degree, that is the least count. Fine. So if I give it the pulse per revolution, so the pulses, for 360 degree we are getting 9 pulses. So if I give it 9 here and press enter, now you can see automatically it is detecting some angular value, that is 960 degrees. We'll move it, so it is 1040, you can show it here. Okay, so if I'm moving it, and you can see the values are increasing. Now it is 1520, 1560, and the edge count is continuously increasing. Fine, I'll move it in the opposite direction. In the opposite direction I'm moving it, and you can see fine. So in that, so you can see this is the part. Fine. So this is the non-quadratic algorithm we have selected here. This is the algorithm we have selected here. Now what happens is that I told you we have two different sensors, and this sensor will give us the direction, that is maybe negative or positive, or maybe in clockwise or anti-clockwise. But if I move it in this direction also, the value is increasing, and if I move it in opposite direction also, so you can see the values are increasing, and it is not giving us the plus minus value. It is increasing only. So the reason is that we are not engaging one sensor, we are only using one sensor. Yeah, both the sensors are emitting the source and it is receiving, but it is not giving us the direction. So angular position we are getting. Right now the angle is 5360 degrees, the angle we are getting. Fine, no problem. Now we'll shift to x2. So in the signal you can see the signal A is blue colored line and signal B is red colored line. So if I select x2, we will get signal A and signal B, that is blue line and red line will be activated. Now let's see what happens. If I move it, so now you can see in the screen, so you can see we have minus 220 degrees. Now we are activating the other sensor also, so as to tell that we bring it in a little here. Okay. Okay, you can see the angle here we have minus 220 degrees, that is in minus. Fine. So now what we are doing is that we are activating the other sensor also. Previously also the other sensor was activated, this sensor, the second sensor. Fine, it was also receiving the data, and it was receiving the sending the data and receiving the data, but now it is giving us the direction. Let's move it in the opposite direction. Now I'm moving it in opposite direction, and you can see we have the value in positive 100, positive 140, 180, 240, and if I move it in the opposite direction, it is giving in minus. And if I keep on moving this one, so you have see 360 degree is our total angle. Fine, but it is exceeding 360 degree and it is reaching now it is minus 540. So what it is showing is that it is continuously, it is not resetting the value. Fine, that means from 0 to 360 degree it will go, and then again it will reset. Nothing such is happening. It is not resetting the value at 360 degree. It was supposed to reset at 360 degree because the highest count is 360 degree, but it is not resetting at 360 degree, and it is going beyond 360 degree. Similarly in the positive direction also, if I move it in opposite direction, it is in the anti-clockwise direction. So I am moving it in this direction, that is anti-clockwise direction, and you can see it is crossing 360 degree and it is 400. So our main second objective was direction. Previously we got the angular position, In the angular position, what we got highest value is 5360 degrees we got. Fine. It was not resetting at 360 degree, but it is continuing. It was continuously reading the value after 360 degree. Fine, that's not a problem. So we are continuously getting the angular position. Secondly, it was giving us the direction also. In the plus direction also, in the minus direction also we are getting. Fine. Velocity obviously we can calculate. Now the third thing is that this sensor, the screw head sensor, which is fixed here in the knob, so it is moving in this direction. So that we will see the middle, the LED light in the middle given in the board. So we'll see how does it work. So we'll just move to X2, and if I select X2 and enable index, because index Z equals to grid line, so I have to enable this one. And if I move this one, now what will I do is that I'll just give one complete rotation. So like suppose this is my knob, so I'm just using my pen as pointer, and if I move it 360 degree, and immediately you have to switch it there, show there. Okay, no problem. Okay, continuously it was reading, no problem, just immediately switch it. So again, let's move one more time. So pen as my pointer, sorry, so I'll just give one complete rotation, switch it there. Yes, so you can see this is the part. So this is the part for 360 degree rotation. So basically here when we are engaging the third part, that is the X4, the index part, in the index part the green line is activated. In the green line, when we activate that, so there what we will have is that it will give me exactly 360 degree rotation, and I'll get to know. Bas, that is the thing. And also in the angle you can see, just see the angle. I'm increasing it 90, 100, okay, 120, okay, 210, 220, 40, 50, 60, 70, 80. Okay, look very carefully. 40, 50. Okay, so it is here. Now what we can see is that since we have activated the index value, the third value, this is the index line, this is the green color line. So now it is every time it is resetting at 360 degree, because it knows that 360 degree is the highest angle we can measure here. Similarly in the positive direction also, in the anti-clockwise direction I'm moving, and just see it. So once I reach 360, it will automatically show me 0. So it is also resetting the value once I engage the third part. So 300 degree, 310, 320, 330, 340, 350, 360 and 0. So also it is showing the 360 degree value, it is showing me. So this is the basic demonstration part. Finally we have here. So basically what we can, using an encoder sensor, what we can do is that we can find out the angular position. Fine. After finding the angular position, since we have two different sensors here, so if I move it in the clockwise direction or anti-clockwise direction, the relative, because these two are marked at a different location, and since relatively it is cutting the covered position, both the sensors are simultaneously cutting the covered position. So because of that cutting and because of this relative position, I am getting the clockwise direction and anti-clockwise direction. In whichever direction I am moving, I am getting the value. Maybe it is giving it in minus and positive and negative direction, the angle. So direction we are getting. Also we are getting the 360 degree value when we are engaging the third part, the index part. So at every 360 degree it is resetting to 0. Fine. So this is the basic idea of the this encoder. So the data we are reading here. So I think that's all for today. This is the basic layout of the experiment, the sensor part, how the LEDs are blinking, from the LEDs what are the values we are getting. Fine. And I think that's all. And one more thing, in the table section we have something which one is leading, like A is leading or B is leading. So in the signal you can see we have signal A and signal B, and we have some blue colored light and red colored light we have here. Fine. So just drag it. Okay, so you can see here this is the blue colored line and this is the red colored line, and in the table you will find that which one is leading, like which have started first, or where is the lead and lag. Fine. In the signal we will just find the lead and lag. So as per the clockwise direction movement and anti-clockwise direction movement, there are some changes in the lead of the two signals, signal A and signal B. So we'll just find, I'll just rotate it in clockwise direction. So in the clockwise direction you can see this is the lead, fine, where the blue line is leading, fine, one more, fine. So you can see here, okay. So you can see this is the lead we can see. So in the clockwise direction we have the lead. So you can see the blue line is lead here in the clockwise direction, and the red line is starting having a lag. Similarly, if I move it in clockwise direction, so in the clockwise direction we have some red one is leading here and the blue one is starting little bit late. Side in anti-clockwise direction. In anti-clock, see this is the anti-clock and red is leading. That is in anti-clock B is leading, signal B is leading, and in clockwise direction B is leading. Fine. So this is the thing you need to write it in the table. And in the second table, the calibration table, it is written that the pulses, the count per revolution or pulses per revolution, what is the value. So the values which we got, count per revolution or pulses per revolution is 9. This is the 9 value which we got, and because of that 9 we are reading the angular value. Fine. So there are two different tables. First table, it is asking for which signal is leading for which direction. For anti-clockwise direction blue is leading, and for clockwise direction red is leading. This is the clockwise direction, the red is leading here. Fine. So that's all we have to write in the table, and also in the conclusion you write everything right regarding the things which I have explained here in the copy. So in the page I have explained here. So write about this thing, what are the target, like we have find the angular position, the velocity, we can find the direction, we can find the number of slots we have here, that is 9. So in the anti-clockwise direction what happens, in clockwise direction what happens, what are the pulses per revolution. So all these things you can get. Fine. So that's all for today, and everything in the class we will explain you in detail. Everything will, the video will be uploaded. So that's all. Thank you.